Alright, we are going to work on this guided practice. Before we get started, there is one more problem up here that is an example for us, and it talks about vacation. Leigh exchanged $50 American money, and she received $60 in Canadian. Use a ratio table to find out how many Canadian dollars she would receive for $20 in American. So they have set that upwards, and we showed $60 in Canadian, $50 in American money. Then over here, they put the $20 in American. Now they had to figure out how we're going to get from 50 to 20. So what they did was they divided by 10 and got 5. What you do on the bottom, you do on the top. And then they multiplied up times 4 to get to 20, and multiplied up times 4 and got 24. So for 20 American dollars, they will have 24 Canadian dollars. All right, if we move down to our guided practice, one thing that I want you to know is no matter what, if you do the same on the top and the bottom, you're okay. So this example tells us that Santiago receives an allowance of $7 every week. How much does he receive after 4 weeks? And they give us this 1 and week 4, and they gave us 2 boxes in between. So logically, if it's 1 blank blank 4, what would we put in there? We would just put in the weeks, right? Week 1, week 2, week 3, and week 4. All right, so hopefully, I'm going to move this over just a little bit because I feel like you can't really see the whole thing. There we go. All right, so if the number of weeks goes up every week by the same, so week 1, then we add 1 and get 2, we add 1 and get 3, we add 1 and get 4, logically we have to do the same on 7. So we have 7, we add 7 more, and we get what? 7 and 7 is 14, plus 7, 21, plus 7, 28. Now, I know I had preached you about doing the same on the top and the bottom, but it's doing the same value on the top and the bottom. So because we doubled this, plus 1, plus 1, plus 1, if we double on the top, as long as you're doing the same motion on the top and bottom, you're okay. So if you're going to keep adding this number on each time, if you keep adding that number on each time, it will still be equivalent. All right, so for 4 weeks, he would earn $28. All right, let's look at Tanya. Tanya runs 8 kilometers in 60 minutes. I'm going to go over the screens. I think I put on the next one. Yeah, that's higher. 8 kilometers in 60 minutes. So we're back at the top. At this rate, how long will it take her to run 2 kilometers? So now they gave us an 8, a blank space, and a 2. So how are we going to get from 8 to 2 in 2 steps? What can we divide 8 and 60 by? We got to go down because going up isn't going to really help us. So if we scaled down, what could we divide by both those numbers? I think we could divide by 2. If we divide by 2, divide by 2, divide by 2, we would get 4 and 30. So now, how are we going to get from 4 to 2? Divide by 2 again, divide by 2 again, and we get 15. Because there's 2 15s and 30, 2 2s and 4s. And so, for 2 kilometers, it would take her 15 minutes. All right, number 3 does not get us anything in our boxes. We have to figure this out. So, Lamika buys 12 packs of juice boxes that are on sale, and she pays a total of $48. So 12 packs, 12 costs her 48 bucks. Determine how much Lamika will pay to buy 8 more packs of juice boxes at the same store. So we need to put an 8 over here because that's the number of juice boxes, and now we have to figure out how in the world to get there. Well, if we use greatest common factor, we would see that 12 and 48 are, they're factors of each other, right? 12 can go into 48. So what if we divided by 12 on the top and the bottom? We would get 1. 12 divided by 12 is 1. And 48 divided by 12, how many 12s go to 48? Oh, that wasn't good. I didn't mean to do that. Sorry about that. All right. How many 12s go to 48? And we get 4. So now, how do we get from 1 to 8? 1 times 8. What you do on the top, got to do on the bottom. So 4 times 8 is what? 32. So if we want to look at how much she will pay to buy 8 more packs of juice at the same store, she would pay $32 to buy 8 more packs. At the bottom it says, how can we determine if 2 ratios are equivalent? How do you think we can determine that? If they are simplified by the same ratio, then they are equivalent. If they can be simplified to the same ratio, for example, 1/3, 2/6, and 3/9 are all equivalent because they simplify to 1/3. So, if they can simplify to the same ratio, they are so we have, what example they give us? They gave us 1/3, 2/6, and 3/9. 1/3, 2/6, 3/9 can all reduce to what? 1/3. All right, take a pause. I know I was in your way to write some of that. Take a pause. Make sure you have that down. If they can simplify or reduce, you know what? I feel like I should write simplify in here instead of reduce, because I feel like using 2 different words is just not a good idea. If they can all simplify to 1/3. Okay, if they can simplify to the same ratio, then they are equivalent. 1/3, 2/6, and 3/9 can all simplify to 1/3. That means that they are equivalent. And if you look back at your problems, the number 3, 8/32, if we divided it, if we multiplied it up or divided it down, they would all simplify down to 1/4 or 12/48 or 8/32. So all those are equivalent because they all simplify down. All right, from now you are going to go into your independent practice. If you have questions, please feel free to let me know. I want you to attempt to do this on your own, even though it's going to be difficult. We're going to do some more practice on this tomorrow. This is the hardest concept to get in ratios. So once you have this down, you're going to be good as gold. I hope you have a great day, and I hope you make great choices.